Hello everyone, our topic for today is a continuation of application of differential equation. Differential equation in electrical circuits. Specifically, we will be talking about the RC circuit, the simple RC circuits. So what we have here is a circuit diagram of an RC circuit. Same with the RL circuit, just that we have replaced the L or the inductance with this capacitance value. So before we derive the equation for the DE of this RC circuit, please take note of the following. Take note that I, or the current, is equal to the change of charge with respect to time, or dq over dt. Then the charge, okay, let me erase, nilapas man, okay, for a while. So we have the charge is just equal to CV, or the voltage is equal to just Q over C, or the voltage across the capacitor. So same method that we have used for RL circuit, we will be using the Kirchhoff's voltage law. So follow the loop here. So we have negative E plus R times I plus the voltage across C equal to 0. Then we will be substituting the value of I and VC. So first, let us move this or transpose the value of negative E to the right hand side. So what we have left is Ri plus Vc equal to E. Then substitute these following values. So we have R times dq. Mulapas Jude siya. Sorry Jude. For a while. So sorry, medyo na-OCD ko. Okay, so what we have is R times dq over dt plus the value of the voltage across the capacitor is equal to Q over C. So this is the value of our equation for differential equation. Now, let us look for an example and solve a problem involving RC circuit. So the problem is, in a series RC circuit, we have 5 ohms, C is equal to 0.01 farad, and E equal to 100 volt. When T is equal to 0, I is equal to 0, or the current is equal to 0. Then the problem is, find the charge at any time T. Okay, let me pause for a while so that I can write it in the whiteboard. So here we have a problem in here. So in a series RC circuit, let me reread it again. We have R is equal to 5 ohms, C is equal to 0.01 farad, and E is equal to 100 volt. At T, when T is equal to 0, I is equal to 0, and then find the charge at any time T. So at any circuit, electrical circuit problem, we must redraw this circuit. So we have series daw siya. So we have here resistor 5 ohms and a capacity series daw siya. So nagasunod lang ang capacitance. So this one, kasi maalaan siya nga voltage. Okay. So we have 0.01 farad and the voltage is 100 volts. So let us derive. We know from the Kirchhoff's voltage law, we will be arriving this equation, R dq over dt plus Q over C equal to E. So substituting the values, so we have 5 dq over dt plus Q over 0.01 equal to 100 volts. So now find the charge at any time T. Okay, so by variable separable, or actually you can use the Okay, let me can use the variable separable or the linear equation solving differential equation, but I opted to use the variable separable. So we have we can divided both sides by 1/5. So what we have left is dq over dt plus 1/5 times 0.01 is just equal to 20q. 1/0.01 times 5 is equal just to 20. Then 100/5 is 20. So let's try to separate it first. So what we have left is here. So we have dq over dt equal to 20 minus 20q. Then we're trying to solve for q, so as much as possible we try to make it a positive variable, so we can multiply negative sign in both sides. So we have negative dq over dt times 20q minus 20. Since negative times negative, positive, so we have 20q. Negative times 20, so have negative 20. Then we can separate it now. So we have, what we have here is dq over 20q minus 20 equal to dt. So now we can integrate both sides. So as you can see, it is better to use or substitute the value of 20q or assume the value of 20q minus 20 equal to u. So we will be let me use a green color. So let u equal to 20q minus 20. So derivative of u is equal to 20 dq, or du over 20 is equal to dq. So substituting it, so let's continue. So we have, so factor out the negative sign, so we have dq left, so we have du over 20, and 20q minus 20 is just u. So what we have left is dt here, and then we can factor out further the 20, so we have 1/20 equal to du over u equal to the integral of dt is just t. And then what we have left is negative 1/20 ln of u equal to t. We cannot substitute the value directly since we have assumed yet the value of u, so let's restate or resubstitute the value of the original value of u. So we have 1/20 ln of 20q minus 20. From the initial value of the charge is, we know that from the given, the initial value of charge is 0. It is explicitly said that the charge is 0 since the current or the change of charge over t is equal to 0. Then consequently, since I is equal to dq over dt, which is equal to I, then q automatically is 0. So the initial value of our q is equal to 0. So it is safe for us to say that at t is equal to 0, we have the value of 0 of the charge then at any time we have q. So substituting that, okay, let us proceed. So actually, to simplify it further, so we can focus at this equation, we can transpose this negative 1 over 20 by multiplying negative 20 in both sides. So what we have left is 20, no more 20, since we multiply negative 20 in both sides. Okay, negative 20. So what we have left is ln 20q minus 20 by 0 to q equal to negative 20t. Then substituting this value, what we have is ln of 20q minus 20, substituting the value of q first, then minus ln of 20 times 0 is 0 minus 20. So what we have left is negative 20 equal to negative 20. So by laws of natural logarithm, we can write ln of 20q minus 20 over negative 20 is equal to negative 20t. So solving for q, we need to isolate the variable q, so we can exponentiate both sides. So we put e in both sides, so e raised to ln is just, it will cancel out, and what would remain is this component here. So we have 20q minus 20 over negative 20 equal to e raised to negative 20t. Then, as you can see, we can cancel out the 20. So what we have left is negative q plus 1 over e raised to negative 20t. Or we can put an q in the right hand side. So what we have left is 1 minus e raised to negative 20 equal to q. Or we can put the exponential here, since it is negative. We can express this in this manner: 1 over 1 e raised to 20t. Okay, let me write it clearly. So this is 1 minus 1 over e raised to 20. So at any time t, we can solve for the value of charge. So this is the final value for the problem. So I hope you have learned something and enjoy our lesson. So see you for the next upcoming lesson.